This time, if we are describing things, we've got a graph of g of x here, and we're going to look at y equals g of 0.5x. Now we have something inside the function. It's going to affect the x value. You can think of that, and sometimes it's going to be easier to use fractions than decimals. You can think of that as 1/2 x inside the function. And everything that's inside the function goes a little bit against what your gut would feel. We multiply by the reciprocal. The reciprocal of 1/2 would be 2/1. We would call this a horizontal stretch by a factor of 2. Can you see that this graph has 4 key points? So you would choose those 4 key points. I'm going to label them from left to right. So we've got -3, 2. Again, be careful with the scales on this graph. We've got -1, 5. 3, 3. And 4, -2. Draw our arrows to show that those points are going to get moved. The only thing we're doing is we're multiplying our x values by 2. So we'll have -6, 2. -2, 5. 6, 3. And 8, -2. And it's always good to do a little bit of a check after you've done a point, because they're super, like the math that you're going to be doing, the mental math that you're going to be doing is going to be so easy, like, oh, multiply an x by 2, that you might start thinking about the next step already. What am I going to do next? What am I going to do next? And when you do that, you have a better chance of making those little mistakes. Like, you're guaranteed, some of you are going to write x by 2 and multiply the y coordinates. Some of you are just going to get so excited about multiplying by 2, you're going to multiply everything by 2. That happened to someone this morning. It's like, what did I do wrong? You multiplied everything by 2. So even though it's easy, you do still have to pay attention to those details while you're doing them. And now we can label these points. So here we're going to have -6, 2, -2, 5, 6, 3, and 8, -2. And join those points. Does it look like it's been stretched away from the y-axis by a factor of 2? Yes. Domain and range again. For the first one, and I'll use set notation, we're starting at -3, less than or equal to x, less than or equal to 4. And the range, we're starting at -2, less than or equal to y, less than or equal to 5. On the blue graph, the domain is now -6, less than or equal to x, less than or equal to 8, and the range is still from -2 to 5. If you think about what we were doing, our transformation was x is getting multiplied by 2. So it should make sense that your range, which are your y values, they don't change. But if you look at your domain and you say, if x is getting multiplied by 2, do you see that your domain, your smallest value was -3, but when that gets multiplied by 2, your smallest value is now -6. And if your largest value was 4, your largest value is now 8. If you had done this in interval notation, Sometimes people make a mistake with interval notation because the interval notation looks an awfully lot like a point, especially if you have the round brackets. And so if you thought of this as a point, I've seen people make this mistake when they write the blue one in interval notation. Can you see what, oops, I almost didn't make the mistake. Can you see what I did? I just multiplied the first thing by 2. But an interval, that's all x values. It should be -6 to 8. It's not a point. Those are all x values when you're talking about that interval. You could, either one is fine. You could use interval notation or set notation. They mean the same thing. Okay, questions for this one are 4 and 8.